Hey everyone, how's it going? Welcome to the stream. So 2 nights ago I was working on implementing support for booleans, which also means enumerations. Yeah, so this is where we were. So basically I started making this example where I have a bool called A that I set to true and then to false, and that led to looking at code generation for it. Let me just get rid of this now. You know what? Let me build this. Okay, there we go. So what we see here is that a bool is really a type of enumerator with values false and true, false being 0, true being 1. So that's at least what this GCC treats it as, or at least what the debug info for it is being treated as. And so then I thought, okay, well, if I'm going to be supporting bool, I need to support enums in general. So I added this weekday enumeration, I should say. Yes, and we can see weekday over here. Oh, hey, Jono. How's it going? Glad you could join. How you holding up in Australia? So, and then in doing this, one of my viewers last stream was making the valid point that you can actually have enumerators that can be set to the same value as other ones. So here, end of days is equal to Wednesday. And then we also talked about having negative numbers, so I added a large one. And this got into the topic of the size of enumerations, which is not given to us here. So I have to determine the size myself, because in order to know what the value of an enum is, I have to read the correct number of bytes for the data type. So all of this has to be covered when parsing enums. And in adding so many values, we also discovered that the stabs format here, the stab format for strings, if the string is too long, it unfortunately does this thing of continuing itself onto the next line. And so then I thought, I guess that's going to happen even for structs. So I made this big struct with long variable names in it. And sure enough, we can see that we have a struct here that spreads out over 5 lines with that // at the end. So yeah. So then I thought, okay, why don't, before I tackle the whole enums thing, make sure that I tackle this problem, the problem of these lines being multi-line. And the way I did that, excuse me, the way I did that was I rewrote my get line to be a bit of a smarter get line. While getting a line, it actually parses the line, and if it's a stab S, like a stab string line, it looks to see if it ends in the line continuation token, and if it does, it continues to concatenate the portions of the string section below. So for example, here for my struct, it basically takes all this, removes this, and replaces it with the next part of the string. And then it does the same thing. It removes this and replaces it with this next string, all the way until it finally replaces it with the last bit of string that has no / at the end. And then it returns a single line, which it'll be line 61. And then the next line that will be returned after that would be line 66. So things are good in Australia. Things are going well in Canada. I mean, I think like where I live in particular, the rates are not great, but statistically speaking, it is still mainly people over the age of 60, 70, 80 that are being the most affected. So it's not great, but it is consistent what we're seeing around the world, right? For us, they are talking about slowly reopening certain services. school for kids, at least for primary school, is not going to resume until the new year, until September. So that's over. I mean, there's only a month left anyway, so it's not really a big surprise. Yeah, and as for me, I continue to work from home. I don't know, and I have no idea if or when I'll be going back to work at this point. So thankfully, this job does allow me to work from home, and it is very doable. But I do definitely miss being at work and being with colleagues and all that. I mean, I have regular video conference calls and chats with people from work, but it's just not quite the same, right? So yeah, basically this works pretty well. Actually, one thing I didn't check, now that I think about it, now that I'm describing it, is when we are done this bit here, that we certainly, we correctly read the next line. I mean, it should happen there, but I should validate that. Right. Well, yeah, that's pretty good. I think I've heard Australia has been pretty good, right? In terms of the whole COVID situation, it's handled quite well. Not too many cases. Am I correct? Definitely. Okay, that's good to hear. Can we just attach here? I just want to see. Hey, where's my... Oh, here it is. All right, so here I am hitting one of the lines that has a continuation token. Yeah, it's the one for weekday, which makes sense. So we should do this, 1, 2, 3, 4, 5, 6, all the way until we get to I to G's, I guess. Let's see here. That test did not test what I wanted to, so let me try that again. Okay, so I gotta be looking at this line here. E, G, and then H. Actually, am I doing this right? Oh yeah, I am. Okay. It does include I in there. So the next line should be my struct t26, small letter t. Let's see here. So we're returning this whole thing as line 61. The next line should be line 66. So let's see that. Yeah, okay, 66. So then we should see 67, and 67 and 68 should be, oh no, that's it, 66. So that's it. It looks like it's good. Perfect. So now let's work on parsing out the enumerator. So for that, I think I'm going to do the same thing I did for pointers, is write a matcher for that one. So these are my examples. Enum type definitions. Okay, so let's start with something similar to pointers, but in our case, yeah, it's not quite like that. It's going to be a T followed by a number. No, actually, yeah. Okay, so it's the enum name colon T. Actually, what did I do here? This here is it's much more similar to regular type definition. So I included the T in there. That's right, like that. And here I put 0 or more. Yeah, I can just match it. I don't really care. T followed by 1 or more numbers equals to, and is it always, oh, sorry, I'm in the wrong place. Here. T and then some numbers followed by E, then here this should be the letter E for enum. I don't know if this T is always going to be lowercase t. I think it is. At least these examples tend to be that way. Oh no, no, yes. Struct is a bit different. I don't know. We'll see. Okay, so then it's followed by E. And now after that, we start the series of enum values. So basically, I'm just going to capture all of that, and then we're going to split on those because there can be many values there. So all of this, followed by an extra comma and a semicolon. This way I don't really need to get rid of the extra trailing comma. There's always this one trailing comma. I mean, I could keep it in there and then, but what's the point? We'll see. So is this good? like that. And then let me just test this out in my regex, that really cool page for testing regex. Bool 22, false colon 0, true colon 1. So you see I can split on comma here. So that's the thing. If I remove the comma here, then I'll end up with a trailing comma there, which, you know, is okay. But this is, I think, is going to be easier to parse. And then for weekday, we're looking at this weekday 25, and then all of these. I suppose I could do the matching here and get all my enum values. Would that work? I'll just have like some n number of groups afterwards. I guess that could be interesting since I'm already doing regex matching anyway. Let me see. So it'd be something like we match this entire expression, and then in there it's basically some tokens, comma, some tokens that we also want to match. And let me see. Wait, let's include the comma in there. Put a star, or at least a plus, I think, for more than one. Does that work? That is not working. Oh, right, because it has to be a not greedy match. Right? How's that going? I know it's because of the greedy match, because I can see what's happening is it's eating up all the way up until this colon here. But normally, is it because I have to put it here? That looks like maybe. So now I got Monday, colon, and then all the way up until a, okay, comma here. Regex is so annoying. I think I got it. Let's see. Not quite, but getting closer. match 2 groups 0. Is there anything more fun than watching someone write regex? Isn't it riveting? I'm not sure why this is not working. And I was sure it was like this, but it doesn't look like it. It's doing the same thing. Does it come after? No, it really does go inside. Okay. That works for here. But then for comma, now colon 0, I want to match 0 followed by a comma. But why does it eat up all the way up to this comma here? Oh wait. Yeah, see, that's still not working. Okay, colon. See if I can remember how this works. Okay, so it does come right after. So then I still don't understand. So this should work, but it doesn't seem to. What a shame. Basically what I'm trying to do here is I've got this sequence, whoops, from Monday all the way to the end here. Like I can even make, let's try like a simplified version just to work on the inside of our regex here. So this is what I have with an extra comma at the end. So what I'm trying to do here is I'm trying to say match all tokens, but not greedily, up until the comma. Then match all the tokens, not greedily, up until the, a colon, and then followed by comma. Also here it actually looks like it's working. So what's the deal? Is this because of the GM? Okay, don't return after the first match. Okay, remove that. Remove multi-line. Oh, so maybe that's what's going on here. We see it now. How does this look? Oh, I do need to do multi-line. No? No, it's still not working. I think I just don't know how to repeat this. And I think that's my problem, is can I do that? Yeah, I think that's it. I can't do the multiple matches here. I don't think there's a way to do this. If I do global, then it works. Okay, you know what? Forget about it. Let's just go back to just capture everything. Yeah, I think that's the thing, is I would need to do a separate regex to capture everything that's inside. All right, let's just do it this way. Now, if we do it this way, oops, again, I'm editing the wrong one. It's here. First match will be the enum name. The second match will be the type definition number. And the third is the values. Key value, comma separated key value pairs. Suppose I should just call it type name. That's what I've been doing everywhere else. So return a match of 1 . All right. So let's see if we can parse out our values here. So we'll say, now for this I will use my string utilities because I have actually something that I've used for split. Here, split. And then for each one of those values, we're going to extract our key value pairs. Now, of course, I need a type to be able to add this to. So let's go do that. So enum types are going to be fairly similar to primitive types, actually. I actually wonder if I should just derive from it, because it will have, well, it doesn't have a format though. That's the thing. So yeah, I won't do that. But it will have a byte size. It will have whether it's signed or not, which is a bit unfortunate, but and now it needs to have its types. Its names with its basically its key value pairs. Trying to think how I want to store the value. I suppose I should just use the largest possible type. And the thing is, do I want to do it this way? I might actually want to store a mapping. Yeah, actually that's what we're going to do. And we're gonna do, this is the part that I'm not sure what I should use. I suppose I'm gonna have to store it in size t, but then we'll have to cast it to assigned type, or cast to whatever the type is gonna be. Now the reason I want to do it this way is because ultimately our debugger is interested in displaying the name for a given value. That's basically what we want to do for our debugger. And it's possible that we'll do the like if we support having the user type in the name, you know, then I'll have to do a reverse lookup, but that could come later. And I don't mind doing a linear search through the map for that more rare case, you know, the one-off case of you typing in a name. But most of the time what we want is we want to read a value from memory and then display the name. So this makes more sense. And of course, we need the name of our type, right? The name of the enumerator itself. If it has one. Yeah, actually I didn't test that. What if I have an enum with no name? What does it do? Because enums are annoying that way, right? Okay, that's actually good. It gives me a made-up name for it. $_0. So I'm guessing if I add more, it'll put $_1. Now there is a question of what happens if I have more than one file. I'll probably end up with duplicate names there, so that's not good. You can even try it. So there's those two. If I go into dummy here, huh. Okay, so, oh, okay, because it's included, it sees this one. All right. It's not really a fair test. I'd have to compile another CPP file to know what would happen. All right, well, let's try and add one of those. Foo. Let's put this in there. And let's make sure it gets compiled. I think it'll get picked up by the compiler automatically because of my make file. So we're back to having 0 and 1 here. And if I open up foo.rst, no? Yeah. So yeah, there you can see that I'm going to have name collisions for unnamed types. So that's definitely something I'm going to have to handle. I'm not doing multiple file parsing stuff yet for the variables, but it's going to come. I think I have something here about it. Here. Also, okay, so watch for cases of generated names for unnamed types. And I suppose this is going to be true even for things that are in anonymous namespaces or internal names. Internal names that may be repeated. Anonymous namespace. Hey, hey, Brahim, how are you? Welcome back. For unnamed enums, the compiler generates names like you don't have to apologize. Of course, we all have busy lives, but I'm glad you're here now. These will be repeated across compilation units. So what I'm going to do for those cases then is, okay, so in these cases, prefix the variable name with, yeah, I'm not quite sure. So I mean, with what? Like, I was going to say maybe prefix it with the file name or the whole file path, which is a bit ugly, especially for anonymous namespaces. Yeah, that's going to be tricky. All right, I'll deal with this later. See, it's very tricky writing C++ debugger. Probably when I'm doing symbol lookup, I should be specifying what the current file is, so that if there are internal names, like internal types, that's the one we use, those that are bound to the current file. It's not always obvious. Because obviously there are types that are being parsed out of headers. Now I do know which ones I'm parsing. I have this stabs here that tells me these types come out of here. So I suppose I know when it's coming out of the main file, like here. So if it's a CPP file, like if it's a non-header, then I can assign these to be part of that file. Yeah, I might have to key my names on the file as well, not just the name itself. Okay. Anyway, we'll keep it simple for now. We'll worry about those cases later. So anyway, we'll have a name. We have value. So for the list, they call it identifier. I don't know if maybe I should call it that, because now name and name is kind of confusing. This is known as the enum name, so this makes sense. But these are the identifiers. All right, let's try that. Let's go with that. Okay, so now that I have that, we can go back to our parser Now the idea, of course, will be to have an add variable, but for now we'll start with just creating an enum type. So the name will be our lsim enum dot type name. Okay, we'll figure out byte size and assigned. So now the goal will be to start assigning values by iterating through our So for this, we're going to split on the comma. The colon. And now the idea is that we take our KVP of 1 Can I do it this way? Oh, maybe this way. String to long, long. I need one that returns a size type. I don't know. I'm calling it value here, but I'm wondering if I should call it like integral or something like that. I don't know. Okay, so this allows me to populate my value to ID. Now while I'm doing this, I need to also keep in mind what the range is of my values and whether or not we have assigned type. So I need like a a lower bound and an upper bound for my values. Oh, also, I can't do this unsigned, because if it's a signed value, I won't know that. I'm wondering if I should literally check for whether there's a negative, you know, like in the string, because there will be a negative, like a minus. Where is it? Here, like this, as the first character. Okay, you know what I'm going to do? I think what I'm going to do here is I'm going to assume that no one's crazy enough to put values that are outside the signed size t range. And if they do, then I'll just try to catch it here. But I think, yeah, well, it'd be very... it just would complexify the code tremendously if I have to try to, you know, manage both, I think. Would it? Okay, let's see. All right, so let's go with what I was thinking. We'll go for the sign type. So I think for that, I'll use pointer diff t. In C++20, what's really nice is that they've actually introduced a new type, s size t, which doesn't exist yet, but see if I'm right. Yeah, it's s size t. Yeah, so it's coming from in C++20. In the meantime, I think pointer diff t will get the job done. This has to be a signed type. It's pretty much the signed version of the, you can see it here. Or I can use int pointer t maybe. Pointer diff will do for now. So we'll say min value and max value. What's it called again? The what's it called? That numeric. I always forget the traits thing in C++ to get like minimal and maximal values for any type. Numeric limits, that's it. It's actually really old, this one. And I think I have to include numeric limits, right? Limits, okay. So actually what we want to do is we just want to set the min value to the max value and in the opposite. Okay, what's the problem here? Oh, it's just a warning. Maybe I should, in preparation for C++ 20, I should define size t to pointer diff t. Do that up here in base. But then I think this would look a lot nicer. And when we move to C++ 20, we can do this. Okay, so we do this so that at the end, isSigned has already been set. Actually, I removed that code. So isSigned will depend on whether the min value is smaller than 0, and our byte size is going to be based on the range. And I already did this for range using log base 2 here. That gives me the number of bits. Oh yeah, I had this ugly hack here. Okay, so let's put a breakpoint here and see if this works. Let's actually make sure it compiles first. Oh wait, that's not right here. All right, let's hit F5 and debug this. Okay, so we've got a hit. This is for our bool. So let's see what this looks like. So our values are false colon 0, true colon 1. We create an enum type. We set its name, which is bool. We set our min to the largest and our max to the smallest. We split. We split our current value. So we've got false and 0. So our ID is false. And our value is 0. Min and max are set to 0, 0. And then we store that. So right now we have 0 mapped to false. And of course, the next one will be true and 1. So now min is 0, max is 1, v is 1. Okay, so are we signed? It should be false. Number of bits, 1. Right. Right, I'm going to need to round that up to byte size. What is it that I need to do? I think I just need to add 1, right? Except if it's already divisible by 8. Add 7, divide by 8. If it's already 1, it'll go to 8, and we cancel 1. Does that make sense? Just add 7. think so. Because like if it's so if it's say 2 bits or whatever plus 7 and we divide by 8, we're going to need yeah, it's going to become 1 because we're basically flooring it. And if we have say 16 plus 7 divided by 8, we're going to go to 2. That makes sense. And if we had, let's say, 31 plus 7 divided by 8, it'll be 4. So that's okay. Yeah, I think that makes sense. Basically, we're computing the minimal number of bits to represent our values in the enum, but then we want to know how many bytes we can fit that in, right? So did I not set the name here? Bool. Oh, okay. Why did it? Oh, wait. I know why. A type already has a name. I need to add constructors to all this. I'll do that later. For now, it's just easier to work this way. Then I won't make these mistakes. Okay, so that should allow me to extract 2 enumerators. So let's see if we get the other one now. Our friend with all the extra values in there. This one here. Okay, so this is the first one. When we're done with that guy, our enum type is this here. So it's a bool, and it has 0 for false, 1 for true. It's a 1 byte, and it is not signed. So here's our next guy. This one is the unnamed one that has 2 values. That's the name currently. 0 to no name 5, 1 to no name 6, 1 and false. That looks good. So this guy was, this is our bool. Okay, so now we've got our weekday. So this one will be interesting to see, because this is the one that has the negative 5,000 in there. So we got 0. Okay, let's just go up to here and see what we've got. So our min value, negative 5,000, max is 2. So we should be a sign type, yes. So number of bits, 12, so we should need 16, so that should be a 2-byte value, and it is. Perfect. Let's see what this guy looks like. So it's called weekday. It has 0 for Monday, 1 for Tuesday, 2 for end of days. So we lost Wednesday. So that's one thing. That's maybe we don't want to do that. Maybe we want to keep the first one and not the last one, because that's what Visual Studio does. So we might want to change that. That should be easy. We just look to see if it's already in the map and not replace it. And then -5000 maps to foo. It's a 2-byte that is signed. Okay. So let me just make that quick change. Actually, what's the trick to see if it's in there, and then if we don't find it, we can insert it at the location it would normally go into. Insert or assign? Is that it? But we don't want to assign. So maybe it's in. Try in place. That's the one. Inserts if the key does not exist, does nothing if the key exists. That's the one we want. Only insert the first identifier mapped to the same value in the enum. This way we only display the first one in the debugger, like Visual Studio does. Okay, so here is this type now. Let's see. Yeah, so number 2 is now mapped to Wednesday and not end of days. Okay, so I think this is good. Okay, so for byte size, we are assuming the compiler will pick the smallest possible byte size to represent, that can represent this enum in memory. Yeah. Always be true, but seems to be for the GCC used, GCC 4 for the targets 6809. So now we've got this type. The next bit is parsing out where we actually use this type. So for instance, we go back to our code in main here. We have our bool A. So A is of type 22. So now what's going to happen is my debugger is going to notice A, and it's going to know it's a certain type, but it won't know what to do with it. Because we will need to add a case for enum types. Here. So we have primitive type here. So let me collapse that for a sec. Collapsing doesn't help that much because it puts everything on one line, unfortunately. So all right, let's do this. The next type is indirect type. So let's squeeze in, because indirect type is basically, in my mind, a generalization for all other types. So I'm going to put enum type here. Okay, so all we really need to do is read the value. If it's signed, we make it signed. And then we look it up. Yeah. Right. It's very similar to what I do for primitive types in terms of how many bytes to read, reading it to a buffer, and then effectively reinterpret casting it. Yeah, I guess I should extract this into something more generalized. Indeed, a lot of this is actually going to look like all this code here. The only difference really is going to be this bit here, where if it's signed, rather than get a string version of the value, I just need the value itself cast this way. And then I'm going to do a lookup in my map for it. Trying to think how I'm going to generalize this. So I could basically make a function that does all this, but instead of turning it into a string, would return the actual value. The only thing is, would I return it? That's it. I don't have the type information. I suppose I could return it as the largest possible value. Yeah, not good. All right, then in that case, I think that I will have to yeah, it's kind of gross. Right. Like this. And then I can do here. Okay, let's take all this out. Okay, so we're going to do pretty much the same thing here. I'm going to basically copy paste it, and later on we'll look at possibly changing that. Wait. Now here, what we're going to do yeah, see, the thing is, even whether it's signed or not, I'm not actually handling this properly. So now we've extracted the enum value. So now we can actually look it up in our list of values here. And of course I gave it it's enum type value to ID dot find enum value. So now if it's not found, which is possible, I suppose, because we might have some garbage in memory, or the user may have forced it to another value. So let's do like this. If it is found, okay. And what we want to do is set display value to iter second. So that gets us the actual identifier. The display type can be set ahead of time. We don't have to wait till here. So we'll do that right at the top here. Or I guess we'll do it at the bottom. So display type will be the name, I think that's it. If this is correct, we should now see our enum value in the debugger. Of course, it has to compile first. Oh yeah. All right, so let's try this. Let's attach our debugger to our debugger. Nice. What's happening now? Am I in control here? Minus 123. What about enum type here? I don't seem to be hitting it. Why not? Okay, so okay, so I thought that I was already collecting these variables because I'm parsing these here. So it seems not to recognize that A is of type 22 for some reason. So you can see here that A and D, which are my two enumerators, are not showing up. I'm only getting a hint for integer, which is a primitive type. So let's see why. How does this work again? Oh, I actually have this handle bool, which is an enum type. Okay, so it has to do with this bit here. Type definition. Oh, I see. Okay. Right. Yeah, that's what, okay, I'm glad I put this to do here. So basically, why this is not working yet is up until now, when we see something like this where a value is mapped to a type, and it has the type itself has no range. Up until now, before I did enums, that meant it was either an int or a void. Types that are not defined with ranges, which we can see up here. int does not have a range. Signed is just an alias, so that doesn't count. And the only other example was void. But now I have something else. I have a, which is mapped to 22. Type 22 here. Where is it? There it is. So I'm going to have to do something here. Now this is type definitions. So wait, it's not type definitions I want. Okay, no, it's variable declaration. So am I not hitting a variable declaration here? Let's see. Oh no, I should. All right, let's debug it. Bool, weekday, and int. So I should hit 3 of these. All right, so here's our first one. So what are we looking at? Yeah, this is A. So actually, we are hitting A. So this should be for bool. Type ref ID 22. Stack offset is 0. That makes sense. Now type ID to type. So this is the problem, isn't it? Is it? Warning, type not found. Okay. Okay, yes. Okay, so I am right. It is because of this has range deal. I need to make sure that the type gets added here. But I'm not parsing enums types there. I am parsing them somewhere else. So let's make sure. Oh, there we go. Right, okay, I think I see. It's because I'm doing a, let me see. Add primitive type, add indirect type. Okay, so if I just create my add enum type, then this would all work. Oops. It's going to be very similar. And in fact, I'm going to move it up here. We want a type def ID, we want a name, we want whether it's signed, we want the byte size, and we would like as well this guy right here. Okay, so now this code here is going to become a little bit simpler. We keep this. We will make our own map here. Okay, then we've got our isSigned. So now isSigned is going to be whether min value is less than 0. Byte size is here. You know what I'll do? I'll just do this here. Auto, or anyway, bool is signed like that, and we'll just put isSigned here. And then finally, we'll move our map into here. Okay, so now we are correctly creating our type and adding it to our map and to our debug symbols are ostensibly correctly. What's the problem here? Oh yeah, this guy, shared pointer, that should be all right. I suppose I should do make shared like I do everywhere else. Oh yeah, I gotta move it, that's why. No, it's gotta be shared. It's gotta be shared because I have more than one of those. Okay. Let's try that again. I don't need to debug it from here. Hit F5. So here's variable A. So this time, are we finding it? We are. Now we add a variable of that type. So let's just go for it. There we go, Enum Types. So let's see how this goes. We're going to read our variable for 1 byte, and we throw, oh, right. What I just ran into is kind of interesting. This is one of those things about C++ where you can easily get caught, and it's a bit sad, but the problem is that it's about scope. So in an if, you can declare a variable like this. Here it's prim type, right? And it's kind of neat because you can initialize, and then it'll be true only if this type evaluates to true. So in this case, the shared pointer, it'll invoke the bool operator on it, and if it's true, it'll go into this branch. And logically, you would think this variable is scoped to this if, which it is. But the thing is, it's not just scoped to this if, it's scoped also to the else, if there are any. After all else if blocks, then the variable is no longer in scope, it's the structure gets called, but it is present in the else blocks, which is a bit sad. There's reasons for that, but what it means is that you can accidentally access this variable in the else, which is what I just did. I had it like this here, prim type. Now prim type is completely available here, but it is a null pointer. It's a null shared pointer. So this is unfortunate, and there isn't really much getting around it. The only way would be to not make this an else if, right? If I remove the else and make this its own if, that would work, except that now I'd be, needlessly evaluating ifs, right? If this one evaluates to true, I don't need to then try to evaluate this one. So it's this kind of, you either decide that scoping is more important, but you take a slight performance hit, although dynamic pointer cast can be somewhat expensive, although this code doesn't run often or anything. But at the same time, it doesn't make sense to do it logically, right? It's either it's this or this or this. It's not, can never be anything else, and so it makes sense to make these else ifs. So that's just sort of one of those things that can bite you in the ass in C++. One of the many. There are many foot guns in C++. All right, so we step. All right, let's try this again. So this time we've read our value and we are 1 byte. So we copy it into V and we cast it into our enum value, and we have something that I did not expect. Wait, actually, maybe it is expected. We haven't set anything yet. Okay, so that's all right. Unknown enum identifier. So that's what we should see now. Let me see. Okay, so now let's see. We step. Ah, there we go. True. And false. Awesome. Monday, Tuesday, Wednesday. Why do I end up here? That's so odd. That looks like a bug. When I step to the last thing here, I somehow end up at line 1 here. Huh. How strange. See, if I step here, That's pretty cool. I mean, I'm gonna have to add something special for bools to just make these lowercase, because it's just weird that it's uppercase. But apart from that, it looks like it's working. Pretty cool, right, Bama? So here we should see that end of days is going to stay Wednesday, and foo should work as well, even with a negative value. And this is a 2-byte value because of this guy. Now, the case of using this unknown enum, I think will not, yeah, that'll be interesting. I don't actually have a name for that type, so. What if I did that weird thing there? Does this work? Ah, so now I gave it a name. Okay. Yeah, so basically, if I wanted to use these, I'd have to just use an integer, and it would end up with those values. Actually, it would be interesting to do this. Let's say we cast to integer our value of D. Monday, Tuesday, Wednesday. This remains Wednesday. This goes, oh, unknown identifier for the negative value. So there we go. So there's a bug there to fix. And then E gets 120. Huh. That's not quite right. Are we actually reading 2 bytes for this? Let's find out. All right, probably would help if I actually attach my debugger. Okay, so this is for A. So I'm gonna hit F5 there. This is for D, so this is one that I'm interested in. So what are we looking at here? It is a byte size 2, and it is signed. So this is the one that's not doing what I expect. Zero. Yeah, okay, so actually this does work up until the last value. So let's see. So that's why Monday works. Okay, then we get Tuesday. Okay, here we go. Now this is where it does not seem to work. Skip the first one. Here we are. Oh. Right. Okay. Copy paste. It's always copy paste, right? Bad, bad, bad. 32, and 64. Should work now. There we go. So that's interesting that we end up with 120. Oh, right, because I can't actually, integer here is actually not the right size. It's being truncated here because int is 1 byte right now. I think if I do long, is long the right type? Yeah. There we go, minus 5,000. This is so weird. Why does it behave that way? This must be hitting, let me see something. I have some output that I can look at. Where is my... Here. So print stream, I think I called it. I'm just curious why it's doing this. If I do a step right here, I'm on line 171, and then I step, and then it puts me at line 0, and I'm back at 172. So it's really doing something funky right here. Let me just quickly check this out. Just very curious. It's the first time I see this. So here we are in step over or out. We get our source location. We are at line 171. Get source location of parent frame. Execute instruction. Check for breakpoints. Current stack depth should break. For step over, as soon as we've changed source line and are back at the original stack depth, we break. So that's what should happen here. So I executed a line, but we're still considered 171. Now that would happen because there's probably multiple lines for 171. Let me just take a look here. 171 here. Right, there's these two. And then there's this one at 172. Hold on. Sorry about that. Okay, so then source location has not changed. Source location changed, same stack depth. We should not break, so we should be back at the same state. This time it's not our first time we enter it. We execute another instruction. We are, oh, there we go. What's this? Line 0. So PC is 197, which is what in hex? C5. Source locations. Actually, $197. Hey, look at that. Why does it say main CPP line 0? Oh, hey, look at that. There is a 0 here. What is up with that? So basically, in this assembly here, you can see that line 171 consists of these two instructions. So 171 is basically assigning 11 to C. So you can see that it's loading 11 into B, and it's storing it at offset 5 from the stack, which is where C is. And then after that, we are pretty much done with this function. Oh, I suppose it's because I don't have a return 0. Now, so there's like an implicit return. You're allowed to do this for main, but so you can see what it does here. So for returning 0, it's going to basically, if you don't put 1, it'll return 0 for you. The way it does that is by clearing B, and then after that, it looks like it loads the effective address of offset 6 from the stack. I'm not sure what that's for. Anyway, so B is used as like the return value. And I don't know why it does this loading of effective address. What is it loading into? forget what that does. But anyway, and then it returns. But what's funny about this is that this bit here, it knows it's line 172, but for the clear B, it assigns it to line 0. So I guess it's because, my guess is what's happening here is the compiler is inserting a return 0, and because it does that, it's not actually in the source code. And so it's saying, well, you know, that doesn't have a line number. I added that for you, so I'm putting that at line 0. Isn't that nice? So, you know, if I put return 0 myself here, and we build, this will change. See? Now it's exactly the same code as before, except now it's at line 173. It's doing the clear B there. If I take this off, it's actually interesting because the return, because it technically happens before the end brace, one other difference is that it gets inserted before the label for the end brace. Like this here, LBE2 corresponds to this guy here. So since it inserts its own return, it actually puts that code after the brace, which is interesting because it's not technically in there. All right, so that's really a special case. If I really don't want that to happen, I think what I would have to do is in my RST parser, I'd have to keep track of the last line that we were at. And if ever I see a 0, line 0, just replace it with that line. Although that does beg the question, could you, no, okay, so there's no line 0. So yeah, suppose I could do that. So many corner cases. I mean, you know, ultimately, I guess another thing we could do is to ignore those. So those would become skipped instructions, I suppose. But I think my state machine assumes all instructions have a known source location. I think. Maybe not. I guess that would be another way of doing it. It's just saying, well, this instruction doesn't have a known source location, so don't actually add one for it. Yeah, that probably would work actually. Yeah, because see, if I don't have a source location, I just return. So we would just keep going. Actually, that would be pretty easy to fix if I'm right. Shouldn't be part of this change, but let's just give it a quick whirl just to see if I'm right. So it would be this, and obviously I would put a comment here. If the compiler injects code, it will be set. It will be the stab data says it's at line 0 in the file, because technically it's not in the file. we ignore these since they don't correspond to actual source locations. So let's see what happens there. And there we go. Now it behaves as expected. All right, pretty cool. Last bit is for bool to have capital F and all that fixed. Let's do that. Just thinking where I want to put that. Could do it in here. Technically, I could do it here as well. Oh, right, there is no toLower for strings because C++ is awesome. Now, did I not do one? Yes, I did. Okay. For bool, GCC emits true and, or I'll say this. Yeah, for bool, GCC emits an enum type with true and false as identifiers. We want these to be displayed as true and false instead. That's the simplest change we can make for this to work. Let's see. There we go. True. A is a bool. So that looks better. Okay. Well, guys, this is great. Pretty happy with this. I think this is actually ready to be committed. A little bit of cleanup, and we can get this merged in. The only thing I want to do is remove this here. Hey, thanks, Bama. I mean, it's not awesome that I copied this from here, but it's okay. Lots of time to refactor this later. Still not, still like on the fence on how I would do that anyway. To be honest, I'm actually not that sad to have all this code in one place. This is the code where we take our types and convert them into the strings we want to display. And the fact that it's all sort of localized in one place makes it easy to reason about. Because I've sort of been on the fence about this, thinking maybe I should, push this into my type hierarchy and ask my type, like here, the primitive type, rather than do it like a dynamic cast on it and then do this kind of work. I could just say, have some kind of virtual function on the type itself and just say, hey, can you format this for me? I might go down that path. We'll see. But then if I do that, all of this code would be in the implementation for one type. And then this code, which is similar, would be in the implementation of that virtual function for another type. And so you end up with this kind of separation of fairly similar code spread out in different files, most likely, which to me is actually sometimes a disadvantage of polymorphism. And this is another form of polymorphism, right? Here we're actually handling the so-called vfunc, the virtual function, inline in one function here. So a little bit like you do at variants. It has that one advantage of bringing in the code all together in one place. So yeah, not sure. I guess we'll see. But I don't want to make any decisions prematurely. I'd rather spread this out all in one place and then make decisions about refactoring later. All right, Jono, thanks for hanging out. I'm going to get off anyway really soon. Just going to commit this and that's it for today. So many changes. Support displaying enums and bools. Enums and bools. I wanted to mention a few other things. Also, oh yeah, in the parser here, parser now joins multi-line stab string into one line. I wanted to mention the fix that we made here. Oh, and I want to put an example. Let me go to RST parser. Example, no return in main. Compiler adds return 0 or injects perfect. So fix jumping to line 0 when stepping instructions that were injected by the compiler, e.g. no return in main. Types are treated as enums with true and false values, identifiers. Okay. Good, good. I think that's it. Actually going to push it. All right, guys, so that's it for tonight. Pretty happy with that. Next week, I think next week we're gonna get started on displaying structure types, structs, classes, unions. So that's gonna be an interesting challenge. So thanks a lot for watching. You have a good weekend too, Bama, and we'll see you next week. Should be on Tuesday, same time, same place. So yeah, thanks for watching.